Honorable assistants, Assalamu alaikum wa rahmatullahi wa barakatuh. We will present the first results of our thesis work entitled Evaluation of Novel Properties of an Advanced Copper Zinc Iron Material as a Future Antibacterial Agent. The goals of our study is to identify the reaction path in the iron copper zinc alloy, developing a theoretical model for XRD refinement, studying different physical properties. We will begin our presentation with general to situate our work, development and characterization, results, conclusion. The antibacterial activities of copper zinc iron oxide nanoparticle were tested against gram-negative Escherichia coli and gram-positive Enterococcus faecalis. We observed copper zinc iron oxide nanoparticle have adverse effect on Escherichia coli compared to the effects caused by individual copper oxide and zinc oxide nanoparticle. Figure shows percentage of live A. Enterococcus faecalis and B. Escherichia coli. Mechanical milling is non-equilibrium process that allows the production of different structures. The repeated phenomena of fracture, welding and re-welding lead to severe plastic deformation of powder's particle, refinement of the crystallite size, introduction of a high density of structure defect, gaps and interstices, dislocation, grain boundaries, formation of solid solution amorphous and intermetallic phases, stable and metastable bases. The content of the rotating reaction chamber with hard balls and a mixture of the initial reagent define the final product. Fracture, where repeated breaks up of the bulk reagent causes the formation of composite particle. The welding phase forms the final morphology of the powders. The production protocol begins with the choice of elementary powders, namely iron and brass. We handled the powders in a glove box under a nitrogen atmosphere to avoid oxygen contamination. Valves are then placed in a planetary ball milling type rich PM400, contains 5 steel balls 12 mm in diameter. The disc and the valves are rotated in the opposite direction. The ball powder's mass ratio is 4 and the disc rotated speed is 350 with enough time of 15 minutes per hour. The powders are recovered after 2, 3 and 4 hours of milling for their characterization. To characterize our powder, we used X-ray diffraction in a breaker D8 type diffractometer in Bragg-Brantano geometry theta do theta using copper K alpha radiation with wavelength in a range of 10 to 125 degrees with an angular measurement step of 0.02 degrees. The obtained XRD are refined by MAUD program, which is based on Rietveld method and consists in adjusting several parameters to adjust the theoretical diffractogram as close as possible to the experimental one using a least square type minimization approach. Adjustment parameters: instrumental, structural, microstructural, mechanical. The minimized function or residue is M, where Wi, Y associated to Yi intensity, Yi absorbed intensity, Yci calculated intensity, Yci the calculated intensity given by the relation flow, where Ybi continuous background intensity, scalar factor, Miller's index, multiplicity factor, Lorentz factor, correction factor, absorption factor, structure factor, peak profile function. The quality of the refinement of the profile is flowed by goodness of feed, depending of the profile and expected factor defined by the expressions where N and P are numbers of measured points, number of refined parameters. The structural microstructural parameters was obtained using A, R, D interplane distance, grain size were calculated using L, where L average crystal size, lambda X-ray wavelength, theta diffraction angle, K constant, beta with at mid height of diffraction peak, and the microstrain rates were calculated using the relation superposition of diffraction spectra of the milled iron copper zinc powders during 2, 3 and 4 hours and milled 1 bar copper zinc XRD spectrum display the appearance of different peaks due mixing of elementary powders. The refinement XRD model is based on an isotropic distribution of the grain size and the microstrains, which give the best fit of the XRD spectra using 4 binary brass phases with deformed grain shape. The overall spectrum is an envelope of several subspectra which reveal the alpha addition of the brass alloy Cu63Zn37, leading to the formation of iron 4 zinc 9 Lorentzian phases with more or less coarse grain and less deformed. Their structure are ordered. On the other hand, the Cu5 zinc 8 phase presents the Gaussian peak and deformed grain shape. The increased milling time caused the appearance of the new Cu3 zinc phase with deformed grain and disappearance of the Cu5 zinc 8 phase. After 4 hours of milling, we noted the formation of new phases at the expense of Cu3 zinc. The iron structure still present with a very deformed grain shape. The evaluation of the lattice parameters depends on mechanical milling phenomena of the iron. For example, A decrease but the brass phases A increase. For iron zinc phase A have an antagonist variation and switch at 3 hours, but in reality it's nearly constant. The variation in crystallite size shows the formation of large crystallite due to welding phenomena. The microstrain rates vary differently with phase structures and is nearly stable with milling time. The highest values of antiphasis boundaries probability are reached after 3 hours of milling, whatever the phase. Dislocation density nearly constant in iron 4, zinc 9 and iron phases reaches a maximum value after 3 hours of milling for Cu63 zinc 37 phase. At 3 hours of milling, the probability increases rapidly for the iron 4 zinc 9 phase due to the increase of the dislocation generation rate. As conclusion, the red belt refinement of the copper zinc iron XRD reveals the formation of different binary phases. The anisotropic model used to calculate the crystallite size and the microstrains is found to be best one. The iron addition in the brass alloy strongly influenced the solid state reaction and the structural microstructural properties of the obtained powder mixture. As a milling powders, iron 4, zinc 9 still the state product phase in the mixture with stable structural A parameter, the highest SFD, the lowest dislocation densities and antiphase boundaries probability and microstrains rate. The effect of copper zinc iron on Escherichia coli as antibacterial agent showed excellent results with will present soon. Thank you for your attention and consideration.